this video, we're going to take a look at space weather, geomagnetic storms, ionospheric scintillation, and total electron content as a means to plan properly for the field when we do our GNSS surveys. So here you're going to see on NOAA's space weather, NOAA.gov's website, the impacts of space weather and GPS. So this kind of explains it. I'm not going to go through all that, but basically the punchline is geomagnetic storms can cause disturbances. The CME flares can cause that. And also the other metrics that we need to pay attention to is ionospheric scintillation and the total electron count. And you can see those links here. I've already got these open on another tab. So you can see here just the explanation of these coronal mass ejections, CMEs, and how they can affect GNSS. Similarly, ionospheric scintillation is another metric that we would want to pay attention to, as well as the total electron count. So another site I would like to show here would just be the space weather scales with respect to these different aforementioned categories. So as far as geomagnetic storms, we pay attention to what's called the KP or K index. And really anything over 5, you really want to pay attention and try to plan around. In other words, if the K index is 5 or more, ideally you're not using GNSS. Now, we have found that it's more problematic when you get up to 6, 7, 8, 9. We've had a couple times in the last year where we've seen numbers close to 8.5, which is very bad, and I would not advise using any GNSS during that time. Really what you'd want to pay attention to here is the geomagnetic storms category. This now brings me to the Trimble GNSS planning site, which allows you to plan ahead of time. So if you know where you're going to work and the approximate dates and the approximate elevation of that locale, then you can plan accordingly. Now we could key in the lat long. In this case, I'm just going to go ahead and zoom out with my mouse wheel. And I'm going to pick where I'm at here in Albuquerque. And I'm just going to kind of ballpark it for right now and just click in the latitude field and just go ahead and pick a spot here. Once I've done that, I'm going to pick my rough elevation here. And I'm going to pick my elevation cutoff. 10 is typical for your elevation mask. Once we've set the elevation mask, let's go ahead and set the day. You can't go too far in advance in time. I found that it's somewhere between 24 and 48 hours, depending on the time you start this. So really it's something to plan for, a day in advance, ideally. I'm going to click on the calendar. I'm going to choose tomorrow, Tuesday, February 18th. And you notice you can change the time zone. So I'm going to set this to my time because that's easier than me trying to figure out UTC. I'm in Mountain here in Albuquerque. I'll go ahead and choose a start time of, let's say, 7 a.m. And let's say I'm going to plan on being out there for 6 hours until about 1 o'clock. I'm going to hit apply. Once I've hit apply, I can kind of step from left to right on this top banner. Notice that you can actually uncheck certain constellations if perhaps your receiver doesn't support those constellations. If I click on satellite library, we can see every individual satellite and each constellation they're associated with. If we go to charts, you can see the number of satellites and kind of the peaks and valleys for when those satellites will be available from that 7 a.m. to 1 p.m. Mountain time frame that I selected. You notice at the beginning I have the least satellites, but again, that's 14 when we look at just GPS and GLONASS. Almost every receiver today is tracking at least those two. If you have a receiver that's well over 10 or 12 years old, then maybe it's GPS only. And you can even see that picks up once we hit about 10 a.m. here. If we go to the sky plot, we can just see what satellites we'd expect to see in that time frame. If you hit play, you can actually see those change over the course of that 6-hour selection. I'm going to go ahead and hit stop. And I'm going to go to world view, which is where we see the most important information with respect to interference, with respect to geomagnetic storms and total electron count and scintillation. So we first want to hit TEC. You'll notice at the top, it's going to load that raster image, and we can zoom in into our area and we can hit play, and we can even speed this up so it goes on this top bar from 0 minutes to 6 hours. And we can see as the time goes on, the electron content is getting higher. None of this is really alarming. If we get up into the top greens, yellows, and reds, that's not so good. If we switch to scintillation, you'll see Once that is loaded, it's similar here, where we see minimal in dark blue, then light blue, then green, then dark green, yellow, and then orange and red for strong. So if we hit play here, we can kind of see that nothing is really changing in the Albuquerque area for that 6-hour period. We have minimal ionospheric scintillation, which is good. Now, the final thing that I would like to check really is looking at the K index. So if we go back to the space weather page, there's a couple ways to get here, but what we're looking for, and it's kind of buried at the bottom, is the planetary K index. You could, of course, bookmark this, and you see that I actually have that bookmarked. And you'll notice that we see 3-hour swaths going back roughly 2 or 3 days, right? So it's 3-hour data, and you can see the most recent was today, and that's that 3-hour data. You see the K index is 2.33. And if you remembered earlier, really the target that I am looking to be under is 5, with some exceptions getting upwards of 6. And you can even see these scales here, right? If we scroll down, there's a little bit of an explanation here. And if you look here, I like to go to data because I can actually look at the last 30 days. If perhaps maybe I had some issues with my GNSS data and I want to verify maybe was this due to space weather, high electron count, or high scintillation. If we click here, you'll see that these numbers are listed in that 3-hour interval. So it goes back 30 days. And if we look at just kind of these numbers here, there's some days that are a little high, but really from today, February 17th, back to January 19th, the highest number that I'm seeing is in the 4s, which is not terrible. So I think the punchline is just to pay attention to these tools, know that you can use them for planning, and it only adds an extra 2 or 3 minutes to your planning for the day, whether it's RTK, base rover, whether it's VRS rover, or whether it's static, and you're going to do baseline processing. It's very well known that PPP, precise point positioning, and base rover RTK are known to be the most affected by space weather. So be very cautious if you're performing static or setting control or setting monumentation when these K indexes are getting above 5. And of course, when ionospheric scintillation is high and or electron content. So anyhow, I hope this video was useful in just kind of understanding and planning for space weather events. Another thing that I'd like to show just here is that we can actually get notified. If you look here under subscribe, that's based on your login. Of course, if you don't have one, you'll have to create one, and they'll notify you when there's any events coming up, which could be quite useful. Lastly, I wanted to show information here on Trimble's Ionoguard. So through firmware on a Trimble R series receiver, if you're on late enough firmware, you can actually get Ionoguard, which will help mitigate ionospheric disturbances. I'm just going to quickly scroll through this article. This kind of explains the solar cycle, the ionosphere, equatorial effects, polar effects, global effects, and then how the technology can be used to mitigate this interference. So if you've got a Trimble device, I would highly recommend looking into this. And if we look at the technical publication, you can actually see a white paper explaining how this works in depth. I hope this video was useful for you, and until next time.